weather and climate often cause concern and curiosity, but understanding the facts behind the phenomena can be a challenge. We're here to help. From the University of Illinois, Urbana-Champaign, and Illinois Public Media, welcome to Weather Realness, a weekly podcast about the skies above Illinois and the world. I'm your host, Maddie Stover, a doctoral student in physics here at the University of Illinois, Urbana-Champaign.
And I'm Jeff Frame, a professor in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois, Urbana-Champaign. Today, we're talking about winter weather in Illinois. In a typical November, Champaign-Urbana receives just under an inch of snow. But this year, we received a lot more.
Please advise take it slow on the roads tonight as most are snow covered. The conditions prove a challenge for drivers.
You know, for tow truck drivers out there, it was a pretty busy weekend. I met with some tow truck drivers over at TMG Towing here in Decatur before the snow really started accumulating today, and they tell me their weekend took off after the snow started falling.
It's coming up on 1 p.m. on Saturday, November 29th. We've got a pretty good winter storm ripping through central Illinois. Big portion of the Midwest. High winds out of the southeast feeding into the storm system. The area flow pressure off to the northwest right now, and then we'll get strong westerly.
Since last Saturday, Champaign and Urbana have both received 8.5 inches of snow. Morrisonville has received 11.8 inches, Paradise 10.5 inches, Lincoln 9.9 inches, and Rochester 11.5 inches.
This has been a snowy start to the winter season here in Champaign-Urbana. In fact, Champaign is only less than half an inch away from tying the snowiest start to the winter season on record. The only snowiest years on record to begin winter have been 1932, 1974, and 1980.
To talk more about this winter weather we're experiencing, we are joined by Andrew Pritchard, meteorologist at Nutrien Ag Solutions. Andrew, thank you for joining us.
So happy to be here.
So, Andrew, you were out in the snow recording for your Facebook page, Sambana Weather, which we love.
Over to the Illinois football game to hopefully get a snow game, but these winds are going to be something as we head through the next 12 hours or so. This is pretty good right now.
What was kind of going through your mind as this winter storm was coming through?
Well, first of all, I was loving it. You spend a lot of time forecasting these big weather events, and once they get here, I kind of just want to go outside and experience that. So I knew that we were going to have some winds with this storm system and kind of just wanted to get out into the open there and see the high snowfall rates with those winds and the low visibility. So it was just a classic winter storm out there. And I knew that, I was hoping people were smart on the roads and also hoping people were enjoying a really snowy start to the winter here.
How about you, Jeff? How was your Saturday?
Well, as a Michigan alum, it could have been better. We lost to Ohio State. But I was still out of town visiting family back near Detroit, Michigan for Thanksgiving. So I was a bit jealous seeing 7 or 8 inches of snow fall here in Champaign-Urbana, and I wasn't around to see it. I'll admit, I'm biased. I love snow. Snow is the best. Now, we did get about 3 or 4 inches Saturday night up in Michigan, but then I drove back Sunday. The roads were great until I pulled into my driveway and saw a 3-foot-high snowdrift in front of my garage. Welcome home indeed.
So, Andrew, you were also at the Illinois Northwestern football game on Saturday. How was the game?
Also incredible. It was a wonderful time just watching the forecast as we were leading up to this game in the days ahead. At first I thought it was just going to be really cold and maybe miserable, but then we started seeing maybe some snow, and then it became a lot of snow and a lot of snow during game time. So I made a plan to go out to the game and just experience what was going to be a really memorable weather vibe at a football game, something I'd never experienced before. So it was everything I hoped it would be. There were a lot of memories made and a lot of really cool things going on there at the stadium that aren't going on during a typical football game.
Again, I was a bit jealous because I've been an Illini season ticket holder for over 10 years. But it's just really tough for me to get to that Northwestern game over Thanksgiving because I'm usually out of town visiting family.
Andrew, as we mentioned before, Champaign-Urbana typically gets less than an inch of snow in November and around 6.5 inches in December. On Thanksgiving weekend, we saw 8 inches of snow. Why are we seeing winter weather so early this year?
Well, the easy answer is we've got a lot of cold air around. To get snow, we need it to be below freezing, and it's usually a slower progression or transition into the coldest period of the winter here in central Illinois. So we've seen a flow of the jet stream from the north, bringing in a lot of cold air from the Arctic. So that was kind of the first stage, bringing in a lot of cold air over Thanksgiving weekend. And then the storm system that we saw on Saturday was a little bit atypical for a pattern like this, which is usually bringing in these reinforcing shots of cold, dry air and lighter doses of snow like the one that we saw earlier this week, a couple of inches there of light powdery snowfall. So if you remember back to the storm on Saturday, we had those very strong winds out of the south as the storm system was coming in. And typically, when we would have a storm system doing that, bringing in warm southerly winds out of there, it would be bringing in above freezing air. And that's when we get that dreaded rain, sleet, snow mix here in central Illinois. So we already had that cold air in place. So the storm system was able to tap into that and create a lot of snowfall here across central Illinois. So the big easy answer is it's been a very cold start to the winter. So the storm systems we've got tracking through are producing snow instead of rain.
And that cold air is coming from the Arctic?
It is coming from the Arctic through the Canadian prairies and then spilling down here through the northern plains into the Midwest. So we've got kind of a big area. It's an upper level low pressure system here off to our north. And so the flow there with the high off to the west is really going from north to south. So it's all about your source region here. If you kind of flip the seasons and think back to the spring, we talk a lot about needing rain and moisture from the Gulf. And so that's our moisture source. So to get cold air, we need to be bringing that air from our cold air source off to the north. And early in the year, that's going to be way up in the Arctic. And so we get that north to south flow of the jet stream, and it brings in that really cold, bitterly cold air.
So another question and a term folks love to throw around, the polar vortex. Jeff, are we in a polar vortex right now?
Well, the polar vortex is always there. It's a semi-permanent area of upper-level low pressure that forms over the Arctic. Up in the upper troposphere, that's about, 8 to 10 kilometers above sea level, up where jet airplanes fly. And there's an even stronger reflection of that vortex up in the stratosphere. That's way up where the ozone layer is. So the polar vortex is always there. And it turns out that when we see cold air outbreaks like this, the polar vortex actually weakens a little bit. And that allows the jet stream to become wavier. And when you have a wavier jet stream, you have these big dips like Andrew was talking about, and those big dips are then associated with cold air intrusions into lower latitudes like here in the Midwest.
So this low pressure system that we have in the Arctic that's, feeding this cold air, is that going to kind of remain consistent? Is that going to change up anytime soon?
Part of that is what's known as the Arctic Oscillation, where we actually have a higher pressure in the Arctic right now, and that forces the cold air and the lower pressure into the subpolar latitudes, like around Hudson Bay in northern Canada. And it's a lot easier to bring cold air, right, from Canada instead of having to bring it all the way down from the Arctic, all the way through Canada and all the way here. And that's what we call the Arctic Oscillation. And that varies on the timescale of weeks throughout the winter. So just because we started out cold doesn't necessarily mean that the entire winter will be cold like this, or even the entire month of December will be cold like this.
So kind of taking it back to some basics, Andrew, how does snow form in general? And then how about freezing rain and sleet, those kind of less desirable forms of precipitation?
Absolutely. So the snow forms, again, like Jeff was talking here, a few thousand feet above our heads. And so the type of snow that we see depends on the temperature and the humidity there in the layers of the atmosphere, again, a few thousand feet above our heads there. So, when we get these different precipitation types, we talk about snowfall. That snow forms in the clouds then and is able to fall through the lower levels of the atmosphere where it is completely below freezing. And so it's able to stay snow and fall all the way down to the ground. And sometimes we can see a layer of warm air come in there, kind of in between. And so we can be below freezing near the ground. We can have a layer of warm air up above our heads and then that cold air again at the cloud level. And so we can get snow forming in the clouds. It falls then and it melts, turns to rain in the mid-levels there, or kind of the middle layer where we have that warm air intrusion. And then it falls back down into the last few hundred or a few thousand feet there where it refreezes into those kind of freezing rain events where the trees and the poles and the power lines and the roads or surfaces are below freezing. And so that's how we can get these freezing rain events. And similar sleet is kind of that refreezing of melted snowfall there that's kind of fallen. So there's a lot of different ways, and they all kind of come down to different layers of near freezing or below freezing or just above freezing air there, just in the last levels here between the cloud and the surface layer there.
Yeah, sleet is a frozen raindrop or an ice pellet It accumulates a lot like salt or sugar, produces a pinging sound oftentimes. Freezing rain is actually a supercooled raindrop. It's liquid water that's below freezing, and then when it hits a cold surface, it freezes on contact. You can try this out on a cold morning if you put a bottle of water in your car and just don't disturb it, and then go out the next morning and shake it, especially if you park outside, not in a garage or something. You'll see that water freeze instantly as you shake it, and freezing rain is a miniature version of that.
Oh, it's a fun little experiment for at home. So over the weekend, we had some really good packing snow, like great for snowmen, snowball fights. And then we also kind of later this week got some more powdery snow, something that would be really nice for like skiing. So what kind of causes something to be more of a packing snow and then something that's a more powdery snow?
Sure, that packing snow is often associated with snow that's going to be closer to the freezing level there because you're getting a layer of moisture there. That layer of water kind of helps the snow pack together in a more dense form there and makes it a better snowball or a snowman, whereas the snow that we saw just a couple of days ago was much more light and powdery in nature. And so it's a lighter, fluffier snow. It's trapping more air in between the snowflakes there. And when you try to pack it together, it kind of crumbles and falls apart there. So it's that little layer of moisture there with maybe a wetter snow that you get with a higher temperature snow event.
Yeah, the scientific term for that is called the snow to liquid ratio, or SLR for short. Basically saying if I take, say, a foot of snow or some amount of snow and I melt it down into water, how much water do I get out of that? Or inversely, I have an inch of rain. How much snow is that inch of water going to produce? Now, that averages around 10 to 12 inches of snow per inch of liquid water, but that can vary from as little as 6 inches of snow per inch of water to up to 20 or 30 inches of snow per inch of water. And again, that really is determined by the temperature and vertical velocity up in the clouds, specifically the layer of the atmosphere in between about minus 12 and minus 18 degrees Celsius, what we call the dendritic growth zone. That's where snowflakes grow into those dendrites that everybody puts on their windows this time of year. At other temperatures, the snowflakes will be plates or they'll be columns, and those don't accumulate nearly as much as those dendrites do. You get a lot of air stuck in there, and that's how you get a high snow to liquid ratio. Whereas a much wetter, denser snow is going to have a lower snow to liquid ratio. And
is it true that each snowflake is unique?
It is true. As Jeff was just saying, there are different types of snowflakes, but then within that, you've got, unique snowflakes as well. If you're having a big dendrite snow event, all those dendrites are going to be uniquely shaped in their own respect. So it is true. Every snowflake out there is unique.
This kind of moisture content that snow has, you touched on earlier, how do you measure that? And then we also see, such a big range in snow depth. Like you'll have these pileups near your garage that you were greeted by. So how do you measure this moisture content? And then how do we determine what the snow depth is?
Well, measuring snow depth, you just need a ruler or a yardstick or meter stick, some measuring device. And you want to go out into an area that's not, shaded under a tree. You want to avoid a snowdrift or an area where the wind blew all the snow away. You want to try to avoid measuring on pavement or on grass. So a nice elevated surface like a deck or something like that, or a white snowboard that people put down for the official measurements is fantastic for that. And what you want to try to do is take 3 measurements in a good area, again, that's not drifted or disturbed in any way, and then average those together. And you can only measure snow to about 1/10 of an inch accuracy, but really it's probably to the nearest ½ inch or even inch a lot of the time because you do see some of that variability. Now, to measure the liquid water content of that's a little more tricky, where you really want to put some kind of a vessel out there, like a rain gauge or a cup or something like that. You let the snow fall in there, and then you just bring it inside and melt it and see how much water you got.
It's a fun story. We actually used to do that just outside the studios here at at Illinois Public Media here at Campbell Hall, and I used to get to be the weather observer here on the weekends and the holidays, and would do just that, go out to the snowboard and stick the ruler in it. And then we also had the big rain gauge out there, so I'd have to bring in a bunch of snow and melt it down. And there's fast ways and slow ways of going about that, but just trying to find how much, if this was rain, how much precipitation we got out of that. But it's a fun experience, sometimes in some pretty wintry elements.
What's the fast way, the microwave?
The fast way was adding some warm water to it. You had to, of course, know exactly how much above, water you were going to put in there. So maybe if you had some snow in there, just adding, a quarter of an inch or 2/10 of an inch of warm water and swishing it around there, and then measuring all of that, subtracting what you added. So it wasn't the microwave, but it was, it's not the best way to add water to it because you're playing with, You're getting silly with it, but the better way to do it would just be patient, let it melt down and measure exactly what was in the gauge. But like I said, fast and quick ways for everything in life.
If you're just tuning in, you're listening to Weather Realness, the weekly podcast about climate and weather. We're talking about winter weather with Andrew Pritchard, meteorologist at Nutrient Ag Solutions, and Jeff Frame, professor in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois Urbana-Champaign. Another interesting winter weather phenomena. What is thunder snow, and have we seen this over the past 2 weeks in Illinois?
Yes, we have seen thunder snow back on the Saturday after Thanksgiving. Thunder snow was reported around Springfield, also around Decatur, even as close to Champaign-Urbana as like Bondville and those areas just west of I-57. And like I said, I was out of town for the storm, but I did hear reports from some friends in the area that they did hear some faint rumbles of thunder with that storm as it came through. Also back in earlier November, if you think back to that cold snap we had kind of a week or so after Halloween, thunder snow was reported up in Chicago, even right in the loop in downtown there with some of the snow that came through.
Yeah, so what is thunder snow? Like, what causes it?
Yeah, so thunder snow occurs when we have a little stronger upward motion within the clouds. To get any kind of precipitation, you have to get the air to go up. And kind of as a meteorologist, one of my rules of thumb is the faster the air goes up, the more interesting the weather's going to be. And so with thunder snow, we get enough rising motion to get different types of ice particles in the clouds. They run into each other and separate electric charges, with the top of the cloud being positively charged and the bottom being negatively charged, just like in a thunderstorm. But the electric field does tend to be quite a bit weaker, or the charge separation tends to be quite a bit weaker in snowstorms than in something like a thunderstorm. So as a result of that, a lot of the lightning strikes, there have been some studies on this, in thunder snow actually emanate from things like tall buildings, radio or other antennas, wind farms, things like that, tend to produce a lot more of those lightning strikes in thunder snow than in thunderstorms where the electric field is a lot stronger. But still, anytime you hear thunder or you see lightning detected, on the radar, on satellite, something like that, not on radar, but on your radar app, on your weather app, something like that, yeah, you should take the same precautions that you would with any thunderstorm. Actually, thinking back to the football game on Saturday, if a lightning strike had come within, I think, 6 miles of the stadium, would they have delayed the game due to thunder snow? I can't think of any instance of that ever. Maybe in Buffalo, New York.
What is it that makes that charge separation less in a thunder snow than in a thunderstorm?
Just the weaker upward motion in the clouds. That's going to yield a weaker charge separation there. That comes, again, from the collisions between different kinds of ice particles.
A true blast of lake effect snow hitting Chicago, Illinois right now. It is coming in sideways.
I'm here on Springfield Ave in just North Champaign area, and like you mentioned this morning, our wake-up call, our 2 a.m. wake-up call was pretty treacherous.
Big time snow flurries here, already starting to stack up on the car in Champaign-Urbana, Illinois, thanks to a band of lake effect snow that extends from Lake Michigan in the Chicago area all the way down to Interstate 57 into east central Illinois. The same thing that happens
And November 9th brought lake effect snow to parts of Champaign County. Andrew, is that unusual this far south? And if so, why?
It is unusual. And so the way that we get lake effect snow here is we're bringing really cold air in over the top of the lake waters, which are, relative to that cold air, quite a bit warmer. Often we're coming out of the summer or the late fall, and so the lake temperatures are still in the middle 60s. So if we're bringing a big shot of air that's in the 20s or 30s, of course, you got a big difference there. And so when that cold air comes over the lake, it rises in the same way that Jeff was just talking about, generating rain or a thunderstorm. And in this case, we can generate some pretty intense little updrafts that are creating a lot of snow in a small area. So we get these bands of lake effect snow that then travel off the lake and run over the land. And the reason that it is relatively rare here in Champaign-Urbana is part because, we're 100 plus miles away from the southern shore of Lake Michigan. So it takes a very intense and focused band of lake effect snow to travel that far, off the lake. But then we're also a bit, south and west from the lake here. And so it comes down to the trajectory of the wind flow there. We kind of need a northeasterly component to our near surface winds, which is not terribly common across this area. So it takes an unusually strong push of cold air over the lake with the right orientation to bring that lake effect snow down here into Champaign-Urbana versus the Chicago area, Northwest Indiana, parts of southern Michigan are much more accustomed to getting that lake effect snow band coming off of Lake Michigan.
Jeff, so sometimes after it snows, especially when the temperatures are a little bit warmer and we have a nice sunny day after, say we got like a few inches of snow, then we have a beautiful sunny day. Sometimes, kind of in a disappointing way, all the accumulated snow will kind of disappear. How does that, happen? Because typically you don't see a bunch of water on the ground. So where does the snow go?
Right. So the simple answer to melt snow, of course, is you get the temperature above freezing. But in reality, it can be a little more complicated than that because we know snow melts, ice melts at 32 degrees Fahrenheit. But even if the temperature doesn't get up to freezing, especially if the sun is out, the snow can what we call sublimate. That is, evaporation is when water turns into water vapor or gas. Melting is when ice or snow turns into liquid water. Sublimation is when that ice or snow turns directly into water vapor. And that does tend to be a bit of a slower process, but it doesn't involve that ice turning into water first and then evaporating. And that happens more often when it's sunny outside and when the air is relatively dry. So that is, the temperature and the dew point are really far apart, or the relative humidity is low. And the other way to really melt snow quickly is not just have it be warm, but actually get the humidity up there, get that dew point above freezing. Because what snow does in dry air is it actually cools the air above it down below freezing, right? The snow is cold and it'll cool the air and make the air an inch or so above the snow cold and below freezing, so the snow won't melt as effectively. However, if you get that dew point, get that humidity up, especially above freezing, the snow can't cool the air down below freezing. So as a result, you end up with warm air above freezing air directly above the snow, and it melts a lot faster that way. So that's why, for example, right, if you see a day where it's sunny and 35 degrees, let's say, you'll melt some snow, but you're really not going to melt that much of it. Whereas if you have a night where the low temperature is above freezing, that means your dew point is also probably above freezing. And so you'll notice sometimes that snow tends to melt a lot more efficiently at night than during the day when it's the same temperature, and that's the effect of the humidity on the snow melt.
And so just for our listeners, oftentimes dew point and relative humidity get easily confused. Can you just clarify the difference?
Yes. So dew point is the temperature you have to cool the air to get the air saturated. And since warm air at saturation has more water vapor in it than cold air, a higher dew point always means there's more water vapor in the air. Relative humidity is basically how saturated is the air expressed as a percent. If the air is saturated, relative humidity is 100%. If we're halfway there, the relative humidity is 50%. But since warm air has a lot more water vapor in it at saturation than cold air does, all right, a 50% relative humidity at 80 degrees Fahrenheit will have a lot more water vapor in it than 100% relative humidity in the middle of a snowstorm at 25 degrees Fahrenheit. So that's why meteorologists like using dew point to measure moisture in the air instead of the more common relative humidity.
How about the snow on the ground now in Illinois? Do we expect the snow to go away anytime soon?
Well, like Jeff was saying just a little bit ago, we talk about these big planetary scale waves, these bigger, jet stream waves as kind of lingering sometimes on the scale of 3 to 4 weeks, sometimes a little less, sometimes more. And as we look out at the forecast here going deeper into December, we see the same kind of alignment lingering here, meaning reinforcing shots of cold air and maybe some lighter doses of snow here. So just to kind of look out over the next 7 to 10 days, you don't see a lot of days with temperatures getting up above freezing. So that, that's going to help this snowpack stay around a little bit. As Jeff just mentioned, there are other ways that we can start to diminish that snowpack over time. So, of course, we'll start looking at how warm are some of these days going to get? Is there the chance we could bring some more snow in, a few more inches to kind of reinforce it? So in the near term, the next week or so, the snow is not going anywhere. Is it going to last all the way through the holidays? That's a bit tougher to answer at this point.
So there's still time to, build a snowman or, maybe do a little snowshoeing, but you might want to get it in the next week or so if you can.
Definitely. It looks like a cold first half of the month of December, but that doesn't guarantee a cold rest of the winter or a cold finish to December either.
Hopefully you were able to get a lot of those outdoor holiday decorations up before Thanksgiving, if you believe in doing that.
I did make it a point. I was like, you know what? The cold and the snow is coming now. We got to just let's just enjoy it and get the decorations out and light it up. So, yep, we're ready.
Oh,
Yes.
Same here.
Yes, the beautiful winter snow kind of really gets us in the holiday mood.
It would be not the same if we wait and then the snow melts and we're all putting up our Christmas decorations in the mud. It would not be the same vibe.
Exactly.
It's beginning to look a lot like Christmas. Everywhere you go, there's a tree in the Grand Hotel, one in the park as well. It's the sturdy kind that doesn't mind the snow.
Well, Andrew and Jeff, thank you so much for joining us.
Thank you for having me.
Yep, always a pleasure.
Andrew Pritchard is a meteorologist at Nutrient Ag Solutions, and Jeff Frame is a professor in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois. Have a weather or climate question you want us to tackle? Leave us a voicemail at 217-333-2141 or email weatherrealness@illinois.edu. Just ahead on Weather Realness, what's the difference between a blizzard and a winter weather advisory? Why are wind chill warnings so important to pay attention to? We'll break down the terms of winter weather so you can survive it.
It's beginning to look a lot like Christmas. Toys in every store, but the prettiest sight